Okay, so we are going to be handling exceptions. So as you can see in our previous code, we're struggling to convert the data because we didn't know what exactly kind of data is the user going to input. Sometimes the user may input a float when we are expecting an integer. The user can even input a string when you're expecting an integer. Okay, so for example, let's stick with the age scenario. Input. So input what is your age? Okay, so what is your age? Then you say maybe once the person takes inputs the age, you want to print age minus 4. Okay, age minus 4. Okay, so this is a simple algorithm. Let us run it and see. So the age is 34. Now 34 as a string, unsupported format, string and integer. This is the string and this is what the integer. As I said earlier, always the input function gives you the data as a string. The input function always gives you the data as a string. Okay, so take note of that. It always gives you the data as a string, no matter what the user enters. And realize that we didn't convert our data into the integer we needed to do the calculations. So by doing so, you can still say age is equal to the integer of the old age, like the age variable before this one. So we are reassigning the integer version of the age to this age. So when I'm to run this and the user enters 18, we get what? 18 minus 4 is what? 14. Okay, so the age has been converted into an integer and we can perform our arithmetic operations on them. Okay, so this being said, now the question being asked, what if the person enters a float? Then let's see, 17.9, and we know definitely we are going to get an error because a string in a float format can't be converted to what? An integer. So our code will fail. So most preferably, people use floats, convert the data into a float most of the time. So let's say if the person enters 70, it still comes out well. 70 is an integer, but still the float function can deal with it. And but then it will come with what? A point zero at the end, and the calculation still works. But what if upon all this hard work, somebody decides to enter apples? Yes, you don't know what input the user will make. What is your age? So apples, it fails. You can't convert apples into a float. So this brings us to the topic of exception handling. So sometimes you might want to raise an exception. So instead of having an error on the screen, you want to have a special quote and unquote type of error that you want to tell the user. Okay, so I'm going to tell the user that try doing this. If it fails, do the opposite. So first, let us look at the syntax for exceptions. So syntax, let me put a hashtag. So the syntax is simple. You start with what? Try, semicolon, then come to the next line, then you indent. I'm putting the hashtag because I want it to be a I want it to be a comment. So you indent. So try, then you write some codes here. So you're telling the computer to try to perform these codes. It could be a lengthy code, it could be just one code, it could be as many as possible as you prefer. So try these codes. Now, in case this code fails, then you put except this. So then you put another code here. Okay. So you are telling the computer to try performing these action. If it fails, it should rather do this action. Okay. So let me use it to solve this problem and let's see. So once we take the person's age, we say try, then we say converting the person's age to what? An integer. You can, because we want to limit the age to integers. So we can say that age is equal to int age. Okay. So convert the age into an integer. Then when you are done, you print maybe age minus 10. So whatever age the person enters minus 10. Now we are done. But should in case when you are converting it fails, that's the except. Should in case it fails, print this instead. Print please input only integers. So this time around, the computer doesn't put an error on the screen for the user. No user wants to see errors in an app. They want to see it as perfect as possible. So please input only integers. So when we run this and the person puts in 18, everything works fine. The 18 is converted to an integer, then minus 10, giving us 8. But if we run it and the person puts in apple or apples and we press enter, please input only integers. So instead of we seeing an error message, it rather does the opposite. Now, it's not always that your exception should be doing a print statement. You can say maybe try creating, or let's say try inserting something into a file. So you have a file and you want to insert a data, or you want to write a data into that file. But then if the file doesn't exist, it will give you an error. So you can tell the computer that try inserting this data into this file. Now, if the computer tries inserting the data into the file and the file does not exist, it stops the try and goes to the except. And in the except, you can write the code that, okay, if you try inserting it and doesn't exist, when you come to the except, now create the file and now insert it. So it's not always that you're going to print something to the screen. Sometimes you can use it to perform alternative operations. So you don't know which operation would succeed. So if this operation fails, then do the other operation. So try this operation, except the other operation. Okay, so the syntax is simple. Try, semicolon, then your codes here, then except, semicolon, then your codes here. So this is a simple try and error kind of message. So I'm done with the content on exception handling. So you just have to follow this format and it's going to handle it perfectly for you. So have a nice day. Bye.